Math doesn't believe or disbelieve. It just asks, can this be proven? So what happens if we take the idea of God, not as religion, but as a hypothesis, and run it through logic, probability, and formal proof? Let's see what math actually says. Gödel's mathematical proof, the logic argument. In the 1970s, mathematician Kurt Gödel tried to express the idea of God in pure logic. He defined God as a being that has all positive properties, like goodness, knowledge, power, basically a perfect being. Gödel's ontological proof deals with what's possible and what's necessary. His key idea went like this. If it's possible that a perfect being exists, then it must be necessary that it exists, because perfection can't depend on chance. The math part checks out. Computers have even verified the logic. The real debate is about the starting assumption. Is a perfect being even possible? Gödel didn't claim proof of God. He proved that if the definition is logically valid, then existence of God logically follows. Another way math approaches this is through Bayes' theorem, the mathematics of probability and belief. It works like this. You start with a prior belief, say a 50% chance that a creator exists. Then you add evidence. For example, the order of the universe, laws of physics, consciousness, religion, or anything you think might point toward or against the existence of God. Each new piece of evidence updates your probability. The equation looks like this. For some people, the numbers go up. For others, it goes down. In simple words, Bayes' theorem is saying, start with how likely you think God exists. Then look at the evidence. If the evidence fits better with the idea of God than without it, your confidence in God should logically go up. The key point is that math doesn't decide the answer. It just shows how rational your belief or disbelief becomes when evidence is added. Then there is the information theory argument, the code of reality. Claude Shannon's information theory tells us, information isn't random, it's ordered, structured, and meaningful. In our universe, information is everywhere. In DNA, which encodes biological instructions, in quantum states, which hold measurable bits of data, and even in the mathematical laws that define how everything interacts. And this information always originates from an intelligent source. In math, randomness creates noise. But life is structured code, billions of bits arranged with intent. So, if reality itself is encoded, who or what wrote the code? Then there is the fine-tuning argument, the precision problem. Every constant in the universe, gravity, electromagnetism, the cosmological constant, or pi, is tuned within an unimaginably narrow range. Change any one by just a tiny, tiny fraction, life will collapse. Mathematically, that's like throwing a dart at one atom in the entire observable universe and hitting it. Either the universe rolled infinite dice and won them all, or the conditions were set by a supreme being. There's one more angle, called the mathematical universe. Some scientists, like Max Tegmark, suggest the universe is a mathematical structure. Not that it's described by math, but that math itself is reality. Think about it. Every law of physics, every particle interaction, every constant, all perfectly follows equations. Maybe God might be a supreme mathematical phenomenon which humans haven't discovered. If reality is entirely mathematical, then maybe God isn't a person or a force at all, but the ultimate self-consistent equation that makes existence possible. In that view, God is simply the reason something can exist instead of nothing, the point where logic itself creates reality. So, does math prove God? Not in a religious sense, but it shows that the concept of a necessary, self-consistent source of existence isn't illogical, it's mathematically valid. In other words, if God exists, math doesn't argue. It quietly agrees. Thanks for watching, guys. If you like such videos, please like, share, and subscribe. And if you have any suggestions, please leave them in the comments.